A long 5 minutes passing through.
Yeah.
Oh, I'll tell you.
Yeah, you did.
How did you get big?
He gave me Twix.
Yeah, don't you like it?
I can't remember.
All right, find your seats. Get out your homework.
I don't have a seat. I need a binder.
Go get your.
I just wanted to.
Why don't you write down the written exercise? Take your attitude first.
Down.
I mean,
Shots
it's
fired.
always written exercises, but
Left and right. Almost always.
Have we had classroom exercises?
I don't think so. I do them all the time somehow, but I don't have a book. So what was the point? Did you have it? What were you going to do? Look it up?
I know we talk to each other a lot. That's why I'm like confused. As to
All right, questions on the homework. Questions on the homework.
How many points did it count?
Same amount of points as always. 10 points.
Count 0, it'll be great.
That won't happen.
Nah, actually not.
No questions? Was that table okay?
If we all collectively didn't do a homework, can we skip it?
No.
Some people did the homework.
No, because
Unfortunately, I didn't. If my parents find out that I didn't do my homework, like I wouldn't be here. Shit, I'll be tied to a stake somewhere in New
On an
England.
ant bed.
Why make it so excuse?
I
On an
did.
ant bed. I would be tied to stake on an ant bed.
No. I said I
And
would
my
tie to a
parents
stake.
would pour honey on it.
Oh God.
Oh, that's hot.
Then that would kill the ants.
Just me. I didn't enjoy it.
I mean, like Honey the Pooh covered in honey.
I'm kidding.
Honey the Pooh?
Yeah.
You mean the
Pooh? Yeah, he's the Pooh.
Get out. Get out right now.
All right.
No, I'm gonna get closer.
Anyways.
Here we go. Here we go. Quiet, please. Grade your work. So it's 1 through 14 all. Most of these were the table.
I'm ready.
So 1 through 8, I'll have 2 answers. I'll just read them from top to bottom. Number 1, 1 to 4, and 1 to 16.
Hey,
Now, if you wrote as just fractions, that's fine. So it'd be 1/4, 1/16. The book answers are all in colon form for the ratio. Goes through all, right? Yeah. Number 2, 3 to 2, and 9 to 4. Number 3, R to 2S, and R squared to 4S squared.
Oh my gosh, I hate it.
I forgot the square.
Remember, the
Square the
ratio of areas would be the scale factor squared.
So do 1/2.
Number 4, 9 to 5 and 81 to 25. Just square those numbers. Number 5, 3 to 13 and 9 to 169. Number 6, 5 to 1, 5 to 1. Hopefully you start seeing some patterns here. Number 7, 3 to 8, 3 to 8. Number 8, root 2 to 1, root 2 to 1. And if you notice, the pattern was the first 2 rows, the numbers were exactly the same. And the last row was the first 2 rows squared. All right, it's number 9. Big honking numbers. All right.
Brilliant.
Oh,
now,
I put no.
No.
So it would be 1 to 25 billion. Is that right? Trillion. Right.
Yeah, because that's million, billion, trillion. 25 trillion.
All right. Number 10, 3 to 4, 3 to 4.
What?
Nah, I can't.
3 to 4, 3 to 4.
6 to 8.
3, 4. Wow, that one's just wrong.
Number 11, 1 to 2, 1 to 4.
I got that one.
Number 12, x squared to y squared. I thought you guys might have some questions on 13 and 14, but
Wait, what was 11?
1 to 2, 1 to 4. Okay. Number 13, 36 to 25, and 6 2/3. And it does say name 2 similar triangles. So, for instance, ABE to DCE.
I think I just kind of.
Number 11, well, you can get those because of the vertical angles there. And what? Oh, two inscribed angles, angle B and angle C, both describe the same arc, so therefore they have to be congruent as well. You could have chosen other triangles as well. So there's more than one, two similar triangles there. I'm sorry, on number 14, not on number 13. Number 14, 100 to 81 and 8. And the triangles that they chose from the book were ACD and AEB. Once again, the same basic idea. You got two vertical angles there. Angle B, I'm just going to say B and D, but it's really CBE and CDE are two inscribed angles that basically describe the same arc. Therefore, they have to be congruent. So there's your angle for those two triangles. All right, that was it.
You know, I did too.
All right, baskets come around. Put your homework in there. We are going to do something. With the exception of the very last one, for examples, this is pretty simple stuff today. I will say the last example that we do, I'll have to walk you through it. It's pretty nifty and neat. The homework is kind of a mixture of very simple and a couple very challenging ones. For the most part, though, this is pretty simple. All right.
I did it.
Do I have all the homework? Hey, you guys are only sophomores. There shouldn't be senioritis starting sophomore year, right? Senioritis is that disease that all seniors get the fourth quarter of their senior year when they basically ask themselves, I've already been accepted to college. I've already passed all my classes. I can literally get an F in this class and still pass high school. Why should I?
Wait, you can actually do that?
Well, remember, to pass we're talking hypothetically here. We're not talking what you should do, right? If you had an A first quarter, you had an A second quarter, you had an A third quarter, you could get an F fourth quarter and pass the
So you're
course.
saying I don't have to do anything.
Well, no. Remember, I said we're talking hypothetically.
Oh my gosh, I got
Right?
no money, so I could just go with
The issue here is what.
Let's go.
Not what can you do, but what should you do. I can go in the bank and demand money.
You never should have told us this.
Should I? No. But I can do it. Right?
Yeah.
And students, teachers as well. Sometimes it's hard to be motivated after spring break to continue the motivation. But I'm saying homework is you just do it, you get credit. You don't do it. I grade every single day at lunch. It's not like I forget to grade and forget to put a zero. I put a zero in immediately. Start doing your homework. Keep motivated. Some of you literally, if you're not going to college, are 2 years away from having to be required to have a job. If you show up to the job like sometimes, but not all the times, you will find yourself fired within the first week. You're not guaranteed or owed a job by anyone. You have to ask for a job. The employer has to be willing to say or take a risk on you. No one takes a risk on people that can't show up and do their job, which is what some of you are not doing in my class, which is your job of doing your homework. That is your job right now, and you will get paid for it because a high school diploma is worth something, and you're going to get a high school diploma by passing your classes. Unfortunately, the payment is delayed until you actually get your first job. Or some of you that start working, anybody working this summer?
I'm working
Probably.
all summer. I'm working right now. So.
I'm on a job right now.
Not me.
A job other than what your parents give.
Although I am getting my license.
I'm working
so.
for my church right now. I'm a janitor at the church.
How much you make?
It's very, 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 it's not even minimum.
It certainly it gives you a different perspective on the slobs, though, right?
Yes.
That leave paper and trash everywhere in their desk.
That was you 8th grade math.
Yes.
Yeah. You should see my basement.
All right. I don't know if you've been told that there has been changes to the PSAT schedule.
Yes.
One change. One change.
You just get one ready.
Monday, you're coming to school.
Dang it.
The rest is the same. There are some other changes, but the only changes for you guys will be what physical classroom. So originally, I've not been told why they made this decision. Originally, all grades are going to be testing this week when we take the PSAT. They pushed it off. I don't know if it's a classroom issue or it probably is. But what the third through eighth will be taking theirs this second week. You will see no difference, right? The only difference that physically we'll have is maybe, I don't know, they haven't published the schedule yet, maybe you will physically go to a different classroom. So, I mean, I can't make any guarantees or what, but this week right here, that third week on the calendar right here, more than likely for a couple of your classes, you may physically go to a different class, but your schedule will still be the normal class schedule. I don't know where, oh, you're going to be testing with Mr. Surratt or Miss West. Those are the two. Those are the two 9th and 10th grade things. 9th grade is 3 hours and 5 minutes. Yours is a little bit longer. I forget what they put out. It was 3 hours and 20 minutes, something like that. But yours is slightly longer. You would die in 6 hours if you had to sit in a chair.
Constructed differently.
Oh, I would literally be vibrating 3 hours.
It's,
I'm gonna need like a 1 hour.
it's they put it out. I believe it's 4 tests in 3 hours. It's
Why is it not at least in the afternoon?
I thought that
Mike,
In the
let me talk.
afternoon, we're awake.
Let me talk. It's 2 language arts tests and 2 math tests. One of the language arts tests is, or so one of the math tests is non-calculator. One of them is with calculator. Which brings me to the next point, which is, hey, no joke. You got to have a graphing. We are not giving you a calculator for this test. I've seen all of you in your hands have a graphing calculator. Make sure you bring your graphing calculator. I'll probably give you this warning. When you get it. Yes. I will put this out every single day until you take the test. So make sure you bring your graphic calculator. If you're the kid that has the cool games on it or whatever, they will be clear. You will lose the game. So make sure you back your calculator up, or at least know how to reload the games back on if you want.
Buy a new
All right,
calculator.
write your homework down, please. And Chris, Hoodie.
Now I have to open it.
I spent years.
If you really think about it, you feel like people need a car. If you
Get a cord for the calculator.
I just put mine all in a folder on my computer, so every time I clear it, I can reload this stuff.
Just get 2 different
They're $100 a piece, so I got better things to spend $100 on than another calculator.
Yeah, like the Ultimate Edition of Monster Hunter Rise.
Mike, did you leave the group
It's
chat?
like $5 for a cord.
And
And
then
then
you would have missed out on me and Dresses and Crop Tops yesterday.
Get a cord back.
Oh, yeah, you didn't go see it.
It does
I forgot that place even
Yes, it
existed.
does.
I had like
If it was a bad
a mental dilemma sometime like a month ago. And
All right, here we go.
Wait, I can't see.
That's the first sign of a stroke.
No, you were in the way. I'm just having a stroke, guys.
It's like part of your face starts drooping, and then you start slurring your words. And
It's a bunch of
your
words.
I
eyeballs start.
literally have strokes like
It's
every
just
second of the
words.
day.
Some people
my back.
have these things called mini strokes. Young people do not generally have strokes. It's an old person thing. But it can happen in young
I'm gonna
people.
find a way to induce stroke.
I hate word problems.
Well, strokes are caused because you get literally a blood clot in your brain.
That's how your brain
And so basically it's killing part of your brain, and that's why you're having problems with your neuromuscular thing. So it's a really important thing that if they want to actually have a stroke immediately, like no joke. I've seen one person having a
I don't
stroke,
give consent.
and it was very obvious. I mean, like very obvious that the person knew something wrong. It wasn't like I think they're having a stroke. It was like
For real.
They're getting a stroke. Get in the hospital.
they're just talking in nonsense, and half of their face was droopy, and I mean you could just tell. And so we called 911, ambulance took them away, and they had a
Just
stroke.
start melting.
What?
Just start melting, you know, like.
No.
Potato
I'm kidding.
Just remember, half your. I'm not the anatomy teacher, but half your brain controls one side.
Yeah, this.
So when you get a stroke on one side, right, then obviously that's the side that's right. I don't know if it's like left side, or right side, right side. That's why I'm not the biology
What if
teacher.
you were to get one of
Ooh, that'd be bad.
Yeah.
All right, here we go. Now let's focus. I said that today was generally a pretty easy class, and it's true. However, looking at the problems, you got to change your frame of reference of how you tackle some of these problems. I chose 3 examples here to try to give you the best, examples that will help you do your homework. Okay, so we're just doing 3. The last one's very hard. The first 2, once you see how they're done, they're pretty easy. Okay, we're going to be doing something called geometric probability. We've been doing geometry all year. It's been a couple years since 8th grade since you've done probability. It combines both geometry and probability. Okay, this is actually pretty fun. Remember probability? What's the likelihood of you rolling, two pair of die?
Some page dice.
All right. What's the probability of getting a certain number? That's this idea of probability. Let's write this down. Box 1. It doesn't need to go in your book of truth, but it needs to go in box 1. Before we give you the definition of probability, let's talk about this thing called an event. An event deals with a game. Listen, please. You play a game of some sort. Now, that could be an actual game like Monopoly or rolling die or card game. It could be an actual game, or it could be something in life. Walking down the stairs. Hey, Chandler, stop. In math, we call this game theory. But we talk about games. Sometimes we literally are, let me talk. Sometimes we're literally talking about an actual game. Other times we're just talking about normal events in a game type scenario, right? An event is one possible thing that could happen when you play the game. I can fall down the stairs. That's one possible thing that could happen if I go downstairs. You're talking about a game, rolling a 1 die, I could roll a 6. Events are a possible, not probable, but a possible outcome during a game. And like I said, just be careful with this word game. It means more than what we think of normally in game. In math, it means anything that you do. So if the game is defined as rolling a die, that's 1, then one possible event could be, hey, I roll a 6. I mean, there's other events, right? You put all the events together, I don't have you write this word down, they're called outcomes. The outcomes are everything that could happen if you play the game. Hey, I could walk down the stairs successfully. Hey, I could trip and fall, right? Those are, I believe, the only 2 possibilities when you go downstairs, okay? Then you've gone down the stairs successfully. Even if you've tripped, right, you haven't fallen until you're actually on the floor, okay?
The task failed successfully.
Right. Okay. So what we're going to be doing today is something called probability. And probability is the likelihood or the chance of an event occurring. What's the probability that I'm going to fall when I go down the stairs? What's the probability that I'm actually going to roll a 6? Okay? Correct. So you remember 8th grade. So events are the things that could happen. You put them all together, those are called the outcomes. Event is one of those outcomes.
This is like the only thing I didn't do wrong.
And the thing about it is most people have good retention on this because we like to say this all the time. Hey, what's the likelihood of, this or that, right?
It's very unlikely that you die.
I know I've said it a couple times in this class. For those of you that do not want to take pre-calculus your senior year, that's the high-level math course that's offered senior year. We will probably, if I have influence, which I should, we will probably offer a class called probability and statistics. And it's of all the math that you do in as an adult, arithmetic and probability are the 2 main things that you use, like on a daily basis.
I've been shocked.
All right. Write this down, please. This is the formula that you will be using today. And Matt already gave me an example of the probability of rolling a 6. He said 1 out of 6. That's what this says. It's a fraction, so it's a ratio. The top part, the numerator, is the number of ways that specific event could occur. Right. The denominator is give me everything that can happen if you play the game. Give me everything that could happen if you play the game. If we're rolling one die, then that's rolling a 1, 2, 3, 4, 5, 6. If you're rolling 2 die, that's everything from a 2 all the way up to a 12. But there's lots of different ways of getting, so for instance, a 4, a 1 and a 3, a 3 and a 1, or a 2 and a 2.
What happens if you're playing D&D?
In D&D, boy, there's a probability, or the number of events or number of outcomes go up. The numerator is how many ways, I always say, to win the game, right? The bottom number is everything that could happen. This is the, in yellow here, the fraction that you will use to do every problem that we do today. Yeah.
So are we going to be using, can we use the probability simulator on our calculators?
You can, but not, today it's going to be geometric probability. You're going to see what it looks like here. But on a standard, and you should get some of these questions on the PSAT, basic probability questions, beyond geometric probability. I would be highly surprised if you get a geometric probability question, but you certainly could get a probability question. Most likely it's something to do with like rolling die. They love those questions.
I love die.
All right. So Matt told me the probability of rolling a 6 is 1 out of 6, or 1 to 6, or the fraction 1 to 6. As human beings, do we like that as the answer?
No.
So what do we generally do as human beings to make sense of this?
1 to 6.
So somebody says, 5 to 17, you're happy with that? Hey, what's the likelihood of today you're going to have a hamburger for dinner and 5/17? Do you like that answer?
Oh, that's an option. 0 out of.
When you talk about probability, generally speaking, hey, are the Broncos going to win? What's the probability this weekend? We generally don't say 1 to 6. What do we generally say?
0%.
We usually make it a percent. So tonight for homework, even though potentially that is the answer, as human beings, we would rather see this as a, so what is 1/6 of the percent? Calculators. What is 1/6 as a percent?
Good question.
Calculators, grab them. Mike is saying 16%. I'm going to disagree with that.
How on earth do you do this?
Round better.
Round harder.
What? If we round to the nearest whole number, we get whole number would be without decimals.
Is it 17%?
17%, right? So that's it as a decimal. That's it as a percent. So the question is, how do you change a fraction to a percent? Divide, top by bottom, multiply by 100. Okay. As human beings, we use this all the time. I bet today you will use this in some part of your conversation. I don't know. There's 99.9% chance that I'm going to eat lunch today. In everyday speak, we use probability, even when it's wrong, right? We like to use this. It's part of being a human, is talk about what are the likelihood of something occurring. As I said, beyond arithmetic, probability and statistics are the number 1 or 2 things that you use, mathematically speaking, as an adult. Okay. So tonight for homework, they're going to give you a scenario, and they're going to say calculate the probability. That's the form.
Get 0.17.
What's 1 divided by 6?
0.166.
It's called rounding.
All right. Okay. So the probability, I got 1 die in my hand, I'm rolling it. Okay. What's the probability of rolling a 4?
What kind of die is this?
6-sided, I should say that.
1/6.
1/6, right? There's only 1 4. There's only one way of winning the game. I got to roll a 4, but there's 6 things that can happen, 17%. Okay. What's the probability of rolling an even number?
3 out of 6.
Which would be? Don't grab your calculator for 3 out of 6. 50%. Okay.
I'm sorry.
Once again, as human beings, even though there are fractions and these are too easy fractions to wrap your head around, we would much rather say there's a 17% chance of doing the first event. There's a 50% chance of the second one. We like that. All right, last one. What's the probability of rolling a 4 or a 1?
2.
Which would be? You don't need to calculate for that one either. not 40%,
30%.
not 30%, not 34%.
What's 17 plus 17?
3%.
Agree, but then we're rounding twice. We only round once. I mean, I'll slightly agree with him, but this the round. We use the round as the last step. 33%, right?
That is not what I got.
Well, you should have gotten 33.33333, which
How
is
on earth did I-
33%.
I accidentally added a decimal in front of the two.
All right.
Wow.
now. This is all 8th grade probability. We're not doing that today. We're doing high school geometry. All right. So the big but here is that we're going to be doing geometry with probability. Now, what's that going to look like? Trust me when I say it's not much more complicated.
That hurts my brain.
I love
By the way, we did all of this so far.
I love this so
It's still
much.
hurting my brain.
Why have you not shown us that image sooner? That helps type everything in.
I think number 2 is 50%. I think you should print this out for us.
Okay. So I'm going to show you one example, then we're going to do 3 of them together. One example, 3 of them. So put your pencils down, look at the board. This is going to be a probability problem. You're going to have some geometric shape. Now, granted, this is a pretty easy one. It's just a segment, right? I'm going to have some geometric shape. Could be a circle, could be a square, could be any shape. And there's going to be a probability problem. So there's going to be a word, so it does require you to read, comprehend, read it slowly, read it multiple times. But here are the words. Read, Cadence.
If the point on segment AB is fixed at random, there's a probability of the point on AC on segment AC.
The easiest way to comprehend this is to take it piece by piece. So what's the first thing that you see to the comma?
Point on
If a point on AB is picked at random, this is the same thing as rolling the die. So I'm picking some point on AB. Which point am I picking? By the way, how many points are on AB? How many points are on AB? Well, infinite, right? I mean, there's only one name point, but there are an infinite amount of points between A and B. We're good? Okay. So I'm picking some point at random. I'm picking that one right there. I picked a point at random. Okay. Keep reading.
what is the probability that the point is on AC?
It was my point on AC, but are you required to pick a point on AC? If you're picking at random, I could equally have wound up right here. So it's not going to be 100%, right? You can kind of visually look at it. Somebody take a guess percentage-wise. He's guessing 75%. You see like the intuitive mathematical concept, you know? Well, it looks like 75% of the area, or I shouldn't say area, the distance is here and 25% here. It's a guess. Turns out we can actually do this calculation. Why? Because it's geometry and we got some numbers here. Now remember, for all probability, that's the formula. The number of ways you can win the game over everything that could happen. Okay? Now, here's where the interpretation of probability and geometry come together. Because how many ways can you win the game? Well, it's not the same as like discrete events like I can roll 1 or 2 or 3. These are distances. So the interpretation is a distance interpretation. Hey, to win this game, where do we have to land? AC. And what's the distance of AC? Okay, but I could also, since it's done at random, wind up anywhere along the segment. What's that distance? So what's the probability? Okay. Calculators. 5/8 is great, but it certainly isn't what we like as human beings.
62%.
So the guess of 75% was off, but at least it was in the, the right ballpark. So we got about 62.5% or 63%. The instructions for homework do not say anything about rounding, I don't believe.
No.
Doesn't say anything about rounding. It also doesn't require you to change things to a percent. I'm just saying as human beings, yeah, tonight for homework, look at the back of the book, it's going to say 5/8 and you're done. Change it to a percent just to give yourself a sense of what's going on. Some of the fractions are going to be really ugly. And you're like, I don't know what that means. Change it to a percent. You'll know immediately what it means.
Is this actually what all the homework is?
This is what questions 1 is. This is question number, wait, sorry. This is question number 2. a little bit of
Are they
question.
all gonna be roughly like
Get a little bit more complicated.
Lovely.
All right. Here's another example.
Oh god, that looks painful.
So I don't know. Maybe this is the beach, and this is the water, right? And you are okay. So here, that's a pretty good interpretation. I like that. So what's the probability that you're going to hit into the water?
99.9%.
That would be if R is like very small.
Okay. So Danny, read it.
It says if a point on the region S is picked at random, what is the probability that a point on region S?
Okay. Notice there's no numbers here. Don't overcomplicate this. S would be the entire region. R would be just the water. So what's the likelihood of you hitting the ball into the water? Well, it goes back to that again. We go back to the probability formula. The number of ways to win over the number of ways that things that can happen.
Is it literally just 1 to 2?
So if you win, right, if you do in fact pick a point, what's the probability that you land in R? Well, R is what? Is R a distance?
No, R is just that.
But what would that be, geometrically speaking?
Cool looking lake.
Yeah, it's
That would be, Chandler, that would be in an area. You get that part? It would just be, hey, I got to land inside R. That's an area. So what's the fraction going to be?
1 to 2.
Well, where are the numbers?
Would it be
There-
like
well,
area?
There's 2 things that
Over
can happen. There's
the area?
one thing that.
Okay. Go ahead, Kate. Say it again.
Area over area?
Now let's specify the areas.
Area 1 over area.
We get more specified than that.
Area R. Wait.
What's the probability that you land in the water? Well, you got to land in the water to win this game. So
Area R or area?
area R over area S. That's the answer. You're like, well, but what about numbers? Well, there's no numbers here to mess with. Okay.
Wait a second, but technically there's 2 things that could happen. Did you also do 1 over 2?
Yeah, but where are you getting these numbers 1 and 2 from?
Well, there's one thing. That would be
Yeah, but that's a name. That's not a value. This is a value. I mean, we don't know what the value is, but this is a value. If you say that region 1 over region 2, I get that. I'm just going to call it region R over region S.
Okay.
You tell me, what's the level of difficulty for this one?
Very high.
Okay, but if I give you this probability explanation, it's impossible. Now you have the explanation. Okay, this is pretty simple. There's one like this, I think. The hardest one, well, we'll say that for the end, but we're going to do a medium one. Okay? We're going to do a medium one. This is honest to God. If I said, go ahead and get started on your homework, I would have every hand, I don't know what to do here. It turns out there's a geometric interpretation of this one. Go ahead, Matt, read.
Every 10 minutes, a bus pulls up to a hotel and waits for 2 minutes while passengers get on and off. Then the bus leaves. If the person walks out of the hotel front door at a random time, what's the probability that the bus is there?
You as human being, right? This is one of those things you want to know. You know, I've been to a lot of big cities in my life, but you know, you have subways in big cities, right? You want to know when you walk to the subway, is there going to be a train here? Or am I going to wait for a very, very, very long time? Okay. So this is one of those questions. What's the probability of something's running on a schedule that when I walk up, there's a bus, train, taxi, whatever, sitting right there?
That's what a schedule is for.
That is what a schedule is for. And that's why when you go to a foreign country, who's going to Europe, right? Do you guys already speak Italian, French, German? And this is why when you walk up to those things, you're like, I don't read. How am I going to get around? So you're more interested, hey, do the buses run frequently? Do the subways run frequently? Because I can't read German. Kind of like that question. All right. Go ahead, Wes, read.
That's what Google Translate. Every 10 minutes, the bus pulls up to a hotel and waits for 2 minutes while passengers get on and off. If the bus leaves, if a person walks out of the hotel front door at a random time, what is the probability of that bus?
So I don't know, as a business owner, this is kind of like business math as well too. You want to make sure certain things happen. When things happen at random, you are interested to know whether you have a high likelihood or a low likelihood of things occurring. That's kind of what this is calculating. All right, let's do the calculation. You're like, well, where's the geometry here? You're talking about buses. The geometric interpretation of this, the big but here, the geometric interpretation of this is a number line. Right? We're going to make our number line start at 0. Because the first thing that happens is someone randomly walks out and stops and says, where's the bus? That's going to be times 0. Okay? How long do we want to make our number line? Because what happens after 10 minutes? The whole thing starts over again. We're told that every 10 minutes, this process repeats itself.
Oh, I didn't catch the 10.
Okay? So the process starts at time 0. What happens at time 0?
Somebody walks out.
No. What happens at time 0?
Somebody walks out the door.
Well, we don't know if a person walks out or not, but what?
It says so.
The bus is
No, that's the question. The statement, though, says every 10 minutes, what happens? The bus arrives every 10. Doesn't say when. Doesn't say 1 minute after, 5 minutes after. It just says every 10 minutes, a bus shows up. And then does what?
Wait for 20%.
It waits for 2 minutes and then jets off. Okay? So the geometric interpretation of this is a number line. 0 is the start of the process. Clearly, we need to go from 0 to the end, which is, now I put an arrow there because it does continue, but it starts over again. Okay? And you said the bus does what? So somehow we got to indicate that it's waiting. What do we want to draw?
Point.
Okay, a point, a region, an area. But at 2 minutes, right, from 0 to 2 minutes, the bus is physically there. And then what happens in this region right here?
It all go bye-bye.
The bus is not there. So yellow means the bus is there. White means the bus is not there. Now, are there other interpretations? Sure. A dot would work as well, too. Maybe some shading or something like that. Bus is there, bus is not there. Now it's that first problem that we did with the segment. It's what's the probability that where do you land? What do you want to happen?
You want the bus to be.
I want the bus to be there, so where do we want to land?
between
Between 0 and 2.
It was in the 0 and 2, but what could happen at random?
2 and 10.
I could wind up right here in the white where the bus isn't there. And many of you already figured out the answer to this one, by the way. Danny, what was the answer? 20%, right? 2 out of 10, 20%. Okay. Now I did it with nice, friendly numbers, but if this had been every 17 minutes, then you probably couldn't do that in your head, right? But 2 out of 10, yeah, that's an easy one to do. Well, yeah, you got to calculate, right? Here's a way of doing a geometric interpretation of a problem that really doesn't involve any geometry. It's just time, but we can have a geometric interpretation. Okay. There is a question like this for homework. And times are not friendly numbers. Make sure you look it over. Hey, how many minutes in an hour?
What's the answer to it?
60. Just remember that. So if you're making a number line, right, and you're starting at, I don't know, 2:20, when you get to 3 o'clock, the time starts over again. How many minutes is it from 2:20 to 3:15?
55 minutes.
Where'd you get that from?
My brain.
The deep regions of your brain? You just had that number sitting there,
Yes.
just waiting for this moment to be used?
No, I took
What's the
60
math?
So since there's 60 minutes from 2:20 to 3:20, which is an hour, you take the 60 minutes and subtract.
There's one way. Other people think of it as an addition problem. From 20 to the hour is how many minutes?
That's a harder math problem than the way I did it.
You did it equally fine. I'm just saying there's another way of thinking of it. From 2:20 to 3 o'clock would be how many minutes? 40 plus another 15, 55. Same math, or I should say same answer, different math. Okay, we good on this one? I said we're going to do how many examples?
3.
Well, there's 1 out of 3. All right, 20%. Okay. If I had to guess the likelihood of this problem being on a test that you see, 100%. It's like if there's a geometric probability problem, it's going to be an archery target. I don't know why, they just like it. It's the easiest one to write as well, too, as a test writing. All right, you're going to have an archery target. I don't know why it's archery. You know, I know why, because it's an easy one to draw. But I'm saying it's always art. They could have drawn anything, okay? But it will be an archery target or darts. They like that one too. All right, Ethan, read.
This question doesn't even make sense.
Well, it's because I haven't read it yet. A person who is just beginning archery lessons misses the target frequently.
You're a noob.
When a beginner hits the target, each spot is as likely to be hit as another.
Because they're not very good at the game, right?
If a beginner shoots an arrow and hits the target, what is the probability that the arrow hits the bullseye?
The key here is this sentence right here. What does it say? If a beginner who is what? More likely to hit the center or more likely just to hit the target? Just to hit the target. So that means at random, right? What's the part of the sentence say now? If a beginner and that's the key there, because most people would say, well, it's a beginner, they're probably going to miss the target as well too. So we're going to assume that they hit the target. That's the only key to this particular problem. All right, so we're going to use that thing. So, well, what do these numbers mean?
That's the possibility.
No. What do the numbers mean?
That's every section.
That's what?
Every section.
So what does 3 mean?
It would be like their chance of hitting bullseye 1 out of 3 because there's 3 sections.
What's the 2 mean?
Oh, it's a larger area.
Okay, so the 3, there's 3 sections.
Wait,
you can
is
hit,
3
which
the
makes it
radius
easier to hit.
of the whole
Okay.
thing?
I guess, I mean, what Wes said, I can see there's 1, 2, 3 regions. Hayden says they're radii. Of the 2, which one do you think is more probable? What? They're radii. Okay, it doesn't ever say that, but yeah, these are radii. So the bullseye is a radius of, now you got to be careful. It says that the radius of the next section is 2, but the actual radius is, it's 1. What's the radius of the outer one? It's 1. Do you see that? And I'm using imprecise language here. I'm saying radius, but I mean the distance of the what do you call this ring?
Yeah.
From here to here is how big? 1, 1, 1. Okay. So the only one that's truly a radius is the bullseye. It's a radius of 1. The inner or the middle ring, I should say, does have a radius of 2, but that would include the bullseye. But if you hit the bullseye, you've hit in the bullseye, correct? So we have to do a little bit of what? Addition or subtraction here for areas. By the way, what's the question asked? Well, what's the probability of doing what? We're looking for a bullseye. Okay. Turns out it's not, because just common sense. Is the area of the bullseye bigger or smaller than the outer ring? Looks like it's smaller, right? I mean, the outer ring, the area of the outer ring looks to be pretty big, right? So it can't be 1 out of 3.
But it's so much easier to hit the outer ring than hit the bullseye.
We got to do some area problems here.
Yeah, I do archery.
Okay, so the easiest thing is the top number. What are we going to put on the top?
6.
What do we want? Numbers? Do we want area? What do we want? We want area. So what's the area of the bullseye? The area of the bullseye is a 1.
That's the radius.
That's the radius. So what's the area of the bullseye?
Yes.
2.
Come on.
It's
What's the
pi.
shape?
Pi radius squared, right?
So the area formula is? So what's the area of the bullseye? Which would simply be 1 pi or just pi, right? Do you see where we're getting that from? 1 squared is 1. 1 times pi is pi. So the area of the bullseye is pi.
Well, that's nice.
But remember, they can hit the entire, anywhere in the target, yes? So what's the area? And remember, anything that can happen would be anywhere that does say he does hit the target or she, right? Say again? Where are you getting the 9 pi?
Because the radius of the whole thing is 3.
The radius of the whole thing is 3, and 3 squared is
5.
9.
and 9 times pi. Do you see where she's getting that? Therefore, it's 1/9, which is 1/9 is not a friendly number that we can wrap our head around. Percentages are.
11%.
So if you hit the target, you only have, if you're a beginner, you only have 11% chance of hitting a bullseye.
What?
That's pretty high though, right?
For a beginner.
But remember, it assumes that you actually hit the target. And I think you can all imagine what happens when a beginner shoots arrows.
Oh.
You
sure,
better be
I'm
wearing
trying to teach.
protective gear, right? And the old school I taught at middle school, and they literally had archery class. And I mean, like with real arrows and, you know, everything. And I was like, oh my word, as a PE teacher, it's like, are you?
I didn't know they had archery.
Yeah.
Yeah.
That's
So
so
it was like in the class that had all the dumb people in it too. Like in my class, all the stupid people got archery. I
Hey,
was so
be careful what you just said. What did you just say?
Okay, so all the people who didn't think.
And you just said that was your class.
Mentally
No, that wasn't my class.
Oh, that's what you said.
No, I said all the other. No,
You said my class.
You said my class.
I didn't say my class.
Yes, you did. That's why I said be careful what you say.
No, I didn't say my
You're
class.
recording, right?
I am. We can play it now. All right. Hey, this next one, I only included, this is a very, I wouldn't expect anyone, honors or otherwise, to get this one all by yourself. I just find this is a really cool one. How many people have gone to the fair and you played one of those games of chances?
I've never been to a fair.
I don't know.
Okay. Are you going to win a game of chance at a fair? Right? You're going to pay a whole lot of money. You're going to
All fair
lose.
games are rigged,
They
so-
make these games nearly impossible to win.
You know
Give me an
the
example of a
basketball
fair game. And I don't mean like a fair as in
Basketball.
equal chance of win, but what's a fair game?
Russian
Like
roulette.
when they
No.
ask you to like throw
1 out of 6.
So they take like these soda bottles and they'll have like a 2-liter Coke or something like
Oh, I
that.
already know that one.
And then you'll take this ring, and instead of the ring being like this, I mean, the ring is like this.
Uh-huh.
And then what's the likelihood of you tossing the ring and it landing right on the top of the soda bottle and
Very
going around?
likely, because
Right.
it's just how.
It's
fair
like,
games are.
they're nearly impossible to win.
And the goldfish died in here.
Sounds like you speak from experience. So
Sister-
here's a fair game, carnival game, right? So it says you're gonna toss a coin. I've seen this at fairs. You're gonna toss a coin onto a table, and on the table there's like it looks like a big game of tic-tac-toe. There's like this grid, like a coordinate plane, right, with the squares. You win the game if your coin lands and it doesn't touch any black line. Okay.
That sounds
Wow.
awesome.
That's
Well, if the square is this big, it's easy to do.
Yeah,
But the squares are going to be very small. Okay. So it says you toss it on a table. Tables are divided into squares 30 millimeter on a side. It means each square is 30 millimeter wide, 30 millimeters long. If the coin rests without touching the line, you win. Okay. What are the chances of winning this if you toss a dime? A dime is 9 millimeters in diameter.
For a dime, that might be a lot easier than water.
For those of you that can't picture it, this is what it means. You toss this on the table. If it doesn't touch a black line, you win. Okay. So we can actually calculate this. This is truly a geometric probability problem. So here's how it's done. Okay. Well, we know the radius of a dime. I said diameter, I meant radius. We know the radius of a dime is 9, and we know that the squares are 30 millimeter. Now I'm going to draw a picture. I believe it's in the book as well too. I'm going to draw a picture that basically describes this. This is not this. This is one of these squares. One of these squares, that the dotted lines don't really appear. One of these squares is depicted here. The circle is the dime. The dime has a radius of 9. The square, each one of these squares right here is 30 millimeters long. So if you can not touch one of the squares, you win. But if you're or lines, you win. But if you are touching one of these lines, you lose. You see where the center of the dime is? If I move this dime around, as long as the center of the dime finished the sentence, as long as the center of the dime is where? In the red, you win. Can you see that? Some smart person came up with this, not me. Okay. If you wind up, and by the way, the shape that it would make would be another square. but the square would be how long? So let's think it out. The radius of the dime is 9. This would be 9. This would be 9. But how long is this whole thing? 30. 9 plus 9 minus 30 minus 18. You get a square that's how big on each side? 12. So it doesn't matter where you toss the dime, it's going to land somewhere either in a square or on a square. But what we can do is we can apply this to the whole darn thing. Anyway, here's the math. Okay. So the math would be 12 times 12. That would be the area of the red.
Times 30.
Times 30 times 30, which would be 900. So there's a 16% chance. By the way, if it was really a carnival game, this wouldn't be 30. It would be more like 10.
Yeah.
Right?
I was gonna say.
Oh no, it would be possible, but it would be so unlikely as to make sure the carnival guy makes a lot of money.
Basically, you'd have to describe the.
When I was
coin into
19,
this.
I got ripped off by a girl at a carnival,
Oh no.
and she was working there.
What happened?
She was like, "Oh, let's
She said, "Hey, come over here, come on." And she goes, "Hey," she was very cute too, and she goes, "Hey, my boss, I'm new at this game. Can you just stand here and talk to me? Because my boss needs to make sure I have a customer in front of me." I was like, "Hey, cute girl, heck yeah, I'll talk to you." So like 2 or 3 seconds, she's like, "Hey, just put some money down here and play this game once. We'll just continue to talk." I was like, "Okay, that sounds reasonable." You know, $20 later, I finally figured it out. Like, hey, she's ripping me off.
Oh my gosh.
So I told her, "Hey, thank you for ripping me off. Very well played. Now I'm smarter, but I will never do this again." But at 19, I wasn't that smart to realize I was getting ripped off.